Welcome. So far we have been talking about what are called first order partial derivatives. We differentiated just once. As with ordinary derivatives, we can also talk about higher order partial derivatives. For the most part, we see only second order partial derivatives in applications. There will be just one example with higher order partial derivatives that we will do, but I will mostly talk about second order partial derivatives. To keep things simple in the beginning, we will just talk about functions of two variables. But if you have more than two, you can still do the same thing. Let's take a function of two variables, f. Then the partial derivatives with respect to the variables are themselves functions. So we can talk about their partial derivatives. If you have two variables, we have two choices for the variable with respect to which to differentiate the first time. And for each of those, we have two choices for the variable with respect to which we differentiate the second time. So altogether, we have four possible combinations. So we can take the partial derivative with respect to x and then differentiate that again with respect to x. So first I take f sub x, another x, we denote it by fxx. If I use the d notation, then I will write that as the partial derivative of f with respect to x differentiated again with respect to x. As in the case of one variable functions, we abbreviate this as d squared f over dx squared. Now we can differentiate the partial with respect to x with respect to y. So first I take the partial derivative with respect to x, which I denote by fx if I use subscript notation, and then with respect to y, so we write that as fxy. Or if I use the d notation, the first derivative is df over dx, the second time it's d over dy, so we write that as d squared f over dy dx. Or I can start with the partial derivative with respect to y and then differentiate that with respect to x. We denote that by f sub y and then x, so it's fyx, or with denotation df over dy and then d over dx, so d squared f over dx dy. And finally, the partial derivative of fy with respect to y with the subscript notation as fyy, or with the denotation as df over dy and then d over dy, which we abbreviate as d squared f over dy squared.